Hi everyone, welcome to the next video on decisions and switch case respectively. In if-else, we will be learning why we use if-else. When we use if-else, we will understand nested ifs. In switch case, we will go through the concepts of fall through, and then we will also see the difference between if-else and switch case. Further, we will also understand and also code how to use if-else and switch case in real Java environment. So before that, let's take a quick look at the flowchart for sequential selection and iterative control constructs. The first one over here, you are seeing is a sequential structure, the one that we use so often and so not. What you see is that we start, but before that let me tell you that the prerequisite to this video is that you already know flowchart. But even if you don't, let me give you a small insight about what are flowcharts, right? Flowcharts are the flow of control. You see this is a command box. This can be an input, output or a process. But now, let me tell you something. Sequential construct is all what we have done till now. If you remember the code where we had taken an example of a report card, we used to have the student, name, class, section, roll number, and it was all sequentially. There was no two paths. There was no a single time when we had to make a decision that whether we need to go through this path or this path. But there is a control flow that Java offers, that all programming languages offers, which we called if-else. This box is called decision box. The work of a decision box is to take a decision, as you can understand by its name. When it's true, it executes a path. When it's false, it executes a path. After executing a block of statements, it gets back to the original code from where it left off. Now, there is another flow for another flow. We call it iterative flow. What a iterative flow does is that a iterative flow starts, it checks a decision, and depending upon the decision is true or false, it takes a path. If the decision is true, we normally go through this path and we execute a block of statements that we have. After executing the block of statements, we update the expression which we use to check the setup. Then we reiterate back and check whether the condition still matches. If it really does, then we again go through this path, do the same step of updating the expression, revert back and check it again. This time if it gets false, we are done with the code and we take this path, get down and follow the steps that we need to. This is called the iterative structure. Now, let's understand how do we convert that flowchart into a real code that will be working. For that, we need to understand the flowchart first. If you have, then let's analyze that flowchart now. So this was the flowchart that we studied in the earlier slide. Now see, you have a command line, you get to the decision making step. Now you have two options, whether you need to execute the commands in this block or you need to execute the commands in this block. And when will you execute the commands in this block? When the condition is true. Right. When will you execute the commands in this block? When the statements or when the decision rather is false. Fine. So, what is the next step? The next step is to convert it into a real life code. Now, let's start from here. we are coming and we see this command interface. So what should be the first thing we must do is we must write this command, right? After you finish off this block of commands, you get to this step. When you get here, you find this decision box. In Java, we interpret decision box as if. So if, then you put a condition in it. The condition here is test case. So hereby we put a test case. Then in order to represent blocks of code, we use curly braces. So we will be using curly braces. We will open the curly braces, and if the condition is true, then we execute this block of codes. Then we close the curly braces. Furthermore, when this condition is not true, what we do is we go in false. So if this condition is not true, then another block of codes are executed, which we call it else block. So we write else, we open our block of codes, and then we come to this section where we have commands to execute if false. Then we close the curly braces. Finally, when we finished executing the entire setup, we get back here. We flow, and the flow of constructs get back to command. After we finish command, our entire setup is ready. So let's revise. We get to commands, we check the decision. If the decision is true, then we execute this block of code, which is same as this. If the statement is false, that is the decision I take is false, then I execute this block of code. And finally, I end up this command. Right? Easy. Next up in the video, we will see what are nested if and why we use nested if. So let's discuss nested if. Now suppose you have to take two decisions at a time. That is, if you follow a path, then you are asked another question. How will you show this thing in programming terms? There we use nested if. That is, two independent questions put up together and combined together. Let's see for example. Suppose I have this flow chart. Here you see I am checking whether a number is positive and is divisible by 3 or not. How will we do it? We take a number as input. Then we check whether the number is positive or not. If the number comes as positive, that is the condition is true, we get to this flow of statements and we check whether the number is divisible by 3 or not. If the number is divisible by 3 as well, then we are done. We print the number is positive and divisible by 3. But if the number is not divisible by 3, we get back and we continue the program at the next statement. And if we get or if we understand that the number is not positive, then what we do is that we execute false block and we understand that the number is 0 or negative because it has not fired and we have not traversed this path. So since the answer is negative, henceforth we get back to the step, we understand and we continue the next statement as it is to be executed. So now let's code. Fine. So how will we code this? If you have seen the previous video or the previous slide and have understand the concept, then you will understand this. This is basically an if block. So we will have a if block first, then we will state whether the number is 0 or not. If it's false, then we print this. Otherwise what we do? We enter another if block. And in this if block, what we will be doing is that we will be checking whether the number is divisible by 3 or not. If the number is divisible by 3, that is it fires and it holds true, then we get here and print the number is positive and divisible by 3. But if it's not, it doesn't fire, then we continue the program as it is. So I hope you have understand the concepts till now. Let's understand what we need to take care of when we handle if-else statement. The next topic is the dangling if-else statement. What is dangling if-else statement? In order to explain this, let me explain to you or give you an example. Suppose we have bought a house. You used to stay there for 2 years and then you evacuated the house and you no longer stay in that house. What happens is that when someone sends you a letter or sends you a post, it might happen that they have your previous address and they send it to a place where it shouldn't have been sent. It should have been sent to your new home actually, but now it won't be. Similar thing happens with if-else statement as well. Let's see the previous example that we saw. But now, the only thing I have done is that I have removed all the braces. So what happens? See this. If number is more than 0 and it fires and the condition is true, then I check whether the number or the 3 is equal to 0 or not. Modulus 3 checks the remainder of the number, henceforth checks the divisibility. Now, if you see, if the number is mod 3 is equal to 0, that is the statement fires, then we get to the next line where we print the number is positive and even. If it is not, then we print the number is 0 or negative. But now tell me what happens if the input is 6. So if you have guessed the output will be number is positive and even, then you were right. Why? Because when you get here 6 is greater than 0, you get here 6 mod 3 is equal to 0. It's true as well. 6 is divisible by 3. You fire the statement. Now tell me what happens if my input is 5. If you have guessed the number is 0 or negative, then you were right. But is the number really 0 or negative? It's not. Right? It's not. So why does this happen? 5 is greater than 0. The statement fires and it enters the if block of the inner if statement. If number mod 3 is equal to 0, is 5 3 is equal to 0? No. But it thinks that this else is basically an alternative to this one. That is, if this doesn't fire, this else is the next part. It must execute. To get it right, let's understand it with how the code will work if we have different line numbers. Suppose when we saw this thing, if number is greater than 0, basically we get to 2. We checked whether this condition is true or not. If this was true, we used to get to 4. And if this was not, then we used to go to 6. Because this, according to Java, is a contiguous set of blocks. Because after each statement, if we don't keep braces, it considers it as a single line. Now, if this is false, it straight away discontinues because this else is considered as a part of this if and not this if. So how can we have a solution to this? Let's check this out. See, now we have used braces. So what happens if this condition is true and it fires, it gets so they say if a number is also divisible by 3, it fires and we are done because we print the numbers positive and even. It is not, it exits. And it knows that it doesn't have an else block to execute, so it doesn't. But if the number is greater than 0 and it doesn't trigger, then what happens? We get to else and we print the number is 0 or negative. Fine, right? So it's already a lot of theory, right? Let's get to the code editor and code something. So I hope you remember this code where we used a report card and printed the student credentials on the report card. Now, let's dive a step further and check whether the student has passed or failed. So it's a decision, right? Passed or failed. We have a question. Now, how will we solve this? So, let's do one thing. We use the if block. We have studied it already. And we check the condition criteria that if average is greater than or equal to 60%, then we conclude that the student. So we have the terminal over here. We enter the section. We enter the name of the student. We enter the class. We enter the roll number. And then we enter the marks in the subject. So let's enter. We enter the third marks. And since we have secured a percentage of 73 and I have passed today. So let's dive a step further and check whether the student has passed with great marks or not. How will we check that? Let's use another if block and check whether the average is greater than 90 or not. If yes, then we print. Hey, the student has, oh, I forgot a space here, passed with distinction. Great, right? Who doesn't want to pass with distinction? Then we produce an else block and we close out the braces. Furthermore, let's compile it. Class compiled and let's execute it right now. So let's enter the section, let's enter the name, let's enter the class, let's enter the role, let's enter the marks. Hey, student has passed with distinction. So now let's try out something more and something interesting that we had seen earlier, the dangling if statement. Let's get back to the code and start removing the braces. Let's remove the else part over here. Let's get rid of this else. Right. Let's remove this. Let's remove this. Remove this. Orientation doesn't matter, right? But if you want to see that, you can because I have kept it. Even I keep it here. doesn't matter. We compile it. We just enter the section, we enter our name, enter my class, enter my role, enter my marks. Oh shit, I got 77, but they're showing I have failed. Right? The pass marks were 60%. How can I fail? This happened because what I showed you in the slide earlier, that is the dangling point. The else saves it, but the E fails it. Understood? So now let's understand logical and. So yesterday we had solved that we had a number, we checked its divisibility, we had the number printed whether it's positive and even, and then we used to close the braces. Otherwise we are printing the number as 0 and negative. Java provides additional functionality where we can concatenate these two if blocks which you are seeing over here. How? Using logical AND, we can write both the statements together using double AND. That is logical AND. What does logical AND do is that it checks whether this condition and this condition is true or not. Only if both the conditions are true, then only the if is triggered and it is executed. Otherwise, it is not. So we have to remember that both the number condition should be satisfied for both the cases. Then we continue as we did. Let us print this block completely. Otherwise, print the number is 0 or negative. Easy, right? Let's code it and see how this works. This was our code. We use AND and we write it. We get rid of this block. Compile it. Now we enter the section, get our name in here, enter our class, enter the role, and enter the marks. Oh, that means, see this thing, since I have got 84, that's why this condition is true, but this is not, hence it shows I have failed. Fine. Let's do it again. Let's get the marks as this time 95 is greater than 60 as well as it is greater than 90, and hence it shows I have passed the distinction. That's all. Now let's get back to Ternary. This is another form or an alternative to if statement. How we do this is, suppose I have it's equal to 5 and I check whether the number is greater than 0 or not. If it's true, we add 1 to it. If it's false, we subtract 1 from it. And what we do is that we can do this by using Ternary Operator, where we take x and we check whether x is greater than 0. If it's true, then this is triggered, otherwise this is triggered. So remember, this is how a ternary operator works. An if condition, this if condition that we are seeing here is basically this. An if condition is placed over here. What happens with this else part is that if this if condition is true, this is fired, the if block. If it falls, the else block is fired. Okay. Though ternary operator seems easy to use, but when you use nested ifs, then it's difficult to implement and it becomes complex. So that's why we don't use ternary operator much when we have a lot of nested ifs. But when we don't, we can easily use it. Fine. Let's get back to the code editor and see how to use ternary if. Now, let us do something more. Let's check what is the highest number that the student has got. How do we check that in if-else? We know, right? We would have get the marks. If mark 1 have been greater than mark 2, then greater than equal to rather, then we would have checked another statement that whether mark 1 is greater than equal to mark 3 or not. If this is true, then let's give a variable name highest, initialize with 0 and put the value highest equal to mark 1 then. If this gets false, we know that highest is mark 2, right? If this entire statement is false, this mark 1 is not greater than mark 2, then what happens? Then we copy this, paste this, and we know mark 2 is greater than mark 1, so we check it with mark 2, and the highest would have been mark 2 elsewise, so we mark 3, and otherwise the answer would have been mark 3. Right? Highest marks basically highest. Let's try to compile it. Compiled, let's run it. Let's give the section, let's give the name, let's give the class. Oh, sorry. Let's run it again. Let's give the section, let's give the name, let's give the class that's 9, let's give the roll number, marks. So you can see I have got the highest marks as 98, right? Why this happens? Because I have my first marks, 98 is greater than 45. It's true, so I get here and I'm checking 98 is greater than 97. Yes, it's true. So this is fired. And the rest, no decision is taken over here. Now let's try to change this into a smaller part. That is, we will be trying to use ternary operator over here. So we are initializing highest with I'm checking the marks. So first condition, what was the first condition? I am checking mark 1 is greater than mark 2 or not. So let's write mark 1 greater than equal to mark 2. This is my question. Now I have to break it. Right. First bracket is the this part. We will be writing the entire this part. In this entire part will be over here, and this entire part will be over here. So let's start. Now, see, I have another if statement over here. That is, I have another decision to take. So I will keep another decision statement. It's mark 1 greater than equal to mark 3. Let me maximize it. Greater than mark 3. Question it. I have to answer similarly. Right? First answer is yes. If this is true, then my answer is mark 1. That is, I initialize highest with mark 1. Otherwise, I use mark 2. Now suppose this fails. What happens if this fails? If this fails, then I jump to this and I start questioning the user whether mark 2 is greater than equal to mark 3 or not. If it is, then I put highest equal to mark 2. That is, my highest will be initialized with mark 2. Otherwise, it will be initialized with mark 3. Let's check. Right? I have my section. Okay, I need to erase this part first. So I am erasing this part. And now I only have this as my executing body. Right? I compile it. Okay, I cannot compile while I'm already having this. Let's reset this. Let's compile it. Let's run it. And let's see it. So enter the section. Let's clear this out. Enter the section. Enter your name. Then I enter my class. Enter my role. Let's enter the marks. Time. The highest marks equal to 100 is fired. Let's understand why. Let's see over here. Is my mark 1 greater than mark 2? No. So the entire if part, this part, that is true part, is kept. I get back here and I'm checking whether my mark 2, that is 99, is greater than 100 or not. It's not. Right? So this is fired, that is else part. If is not fired because 99 is not greater than 100. And that's why I am getting 100 as my highest marks. So the next video is on switch case. Switch case is another decision making body, but it's faster than if and it's efficient than if. Let's see how switch case work and how we can handle a switch case statement. Let's first see flowchart to code conversion. What happens? You take a single expression and you check that expression whether it is equal to what I am looking for or not. If it is, then I get here. I execute that block of code and then I exit. If it is not, I fall and I check whether this is equal to the second case. If it is true, I execute the second block, otherwise I fall. Similarly, if this is equal to constant 3, then I execute that code of block, otherwise I fall. And if it is not, then I execute a default block of code. Now, how do you convert this into real life programming mode? I use a switch expression. I check whether the constant, first constant, and I use case. These keywords are important, switch and case, because they will be used to create the switch case block. Otherwise I break it. I use case 2, otherwise case 2 if it's successful then execute code block 2, otherwise break it. Case 3, check it and break the default. Default is executed if none of the code matches. Okay. Now, suppose you study in a school, and in your school there are three sections A, B and C, and depending upon your section, decided that whether you are a boy, you are a girl, or you study within a mixed group. Because section A has boys, section B has girls, and section C has both boys as well as girls. So how will we do it? Let's try and do it using a switch case block. Let's take this. Let's take section in, close this. The first case will be A. Always remember, case in cases whenever there is a character, we use single quotes to explain that I am using a character. After you have this case, I'm printing that voice section. Similarly, case B is always followed by a colon. Similarly, I will have a case C as well. And then we have a default case. That is, if all the three cases doesn't match, we print. Let's enter the section. Let's enter the name. Let's enter the class. Enter the role. Let's enter my mark. Here it's a split. I study in voice section because this case has matched. Okay. Suppose another example where is my name, my class, my roll number. Oh, I have again entered the section. Let's enter my section as E, name, class, his roll number, marks. And then see what the output is. We don't have this section in our school. So what happens? It checks B doesn't belong to this case, E doesn't belong to this case, E doesn't belong to this case, hence the default case is fired. Now let's understand something that we had earlier seen in if-else, that is case handling. When we don't see or when we don't realize the mistakes or the corner cases, we can fall in trouble. Let me aware you of such a corner case or such a trouble that can happen with switch case as well. So this is Mark, and Mark is upset, and Mark doesn't want to survive. He is very upset with what is happening around. He is stuck at his room and he cannot leave his room. He is within this lockdown, so he doesn't know what to do. What he decides is that he is going to jump off from the roof of his building. So Mark climbs the roof of his building and Mark starts to jump. He jumps and he falls in roof number 1 and his neighbor number 1 sees him. Fine. Now tell me what happened if I remove the plank of number 1. What happens is that he falls to roof number 2 and neighbor number 1 and 2, both of them sees him now that he's jumping. What happens if I remove 1, 2 and 3, all of them? What happens is that he jumps and he falls straight away into the last one. That is all the cases 1, 2, 3 and the last one, that is the ground floor security, has also seen him. What do we understand from here? Before that, Mark has to tell you something. Mark is upset because he survived. He can't withstand the lockdown conditions so long. Let's analyze it. So what saved him? If you get to see the code or see the example, you will see that in the house I have got planks. Each and every floor has a plank, and this plank is equivalent to a break statement. But each neighbor here in the example is basically cases. What happens is that the break statement helps him from falling. Whenever you remove a break statement or whenever you remove a flag, he falls, and this is called fall through. Let's understand this concept using the code readers. Remove the break statements. Let's remove it from here first and compile the code. Let's run the code and let's enter the sections. See what happened? I have got both the answers. Right? That is, I have traversed here. I have not found a break statement. I have fallen. I have checked this and I have printed this case as well. What happens if I remove break from here and here as well? I compile the code, I run it. Oops, that's way too much. Leave it for now. Just understand the concept of switch case. And see this. I have traversed this. The neighbor number 2 has also seen me. Neighbor number 3 has also seen me. And then I have finally fall over here. So this is what you need to understand very importantly. That each and every case and each and every break is a plank. You remove a plank. So we have already seen what fall through is. Now let's understand the difference between switch case and if-else. Switch case only performs the equality check. We have seen that switch case only deals with numbers 1, 2, 3 or anything like that. It only checks equality, whether I have the given input as 1 and whether it is equal to 1 or not. It only checks that. It checks nothing more. It checks the equality only. Whereas a if-else can perform logical and relational operation. It can perform greater than or less than, as we have seen earlier, whether I have passed or failed. I can check that. I can check that. I can perform logical expressions like and or. I can use or as well. With switch case, I can only check using the same value. When I use switch A, when I use switch case, I clearly mean that I cannot be using anything more. I have to use switch only. With switch case, I am always testing the same value. Always remember, I am always testing the same value with switch case. That is, whatever I use in switch A or switch B or switch C, whatever variable I am using, I am always checking that variable in my entire cases. Whereas for if-else, it's nothing like that. We can check any complex expression in if-else. We cannot handle ranges in switch case, but we can handle ranges in if-else. We can check whether a number is greater than 9 and whether it is less than 70 or not. We cannot do that for if-else. If-else cannot handle that range. Switch case can handle floating point literal. I can uh, I cannot use 7.2. I cannot check whether a number is equal to 7.3, but I can do it in if-else. It's more efficient and it's less efficient. You must be thinking, why is it more efficient than if-else? All the conditions or all the differences I have seen earlier are actually vague, are actually false. It's because switch case offers you reliability. It's fast. You go and check each and every house. You don't need to check a lot of conditions, a lot of things that if-else does. Switch case is far more easy to use, and that's why switch case helps you understanding the concepts well, in understanding and doing the logic easy. So I hope you have understood why we use if-else, why we use switch case, how to handle tangent pointer exceptions in if-else, how to handle floating point, or how to handle uh, fall through in switch case, and each and every concept is clear. In the part 2 of this video, I will show you several questions and we will be solving several other problems. But before that, I will cover methods. When I will be covering methods, let me tell you something, that when I will be covering methods, I will be leaving for loop aside for some time, and then I will be covering methods. I will cover methods and then I will get into for loop. So stay tuned for that. Thank you. Till then, please like, share and comment, and if you have any queries, do ask me whenever and however you feel like. Thank you.